Hello guys, so welcome again to our sessions of algebraic expression and identities. Okay, so in our last video we discussed about terms, coefficients, factors, and we discussed about monomial, binomial, trinomial. In general, we call algebraic expressions with one or more terms with non-zero coefficient and the exponents of variables having non-negative value as polynomials. So polynomials are general representation, general term for a monomial, a binomial, a trinomial, etc. For any algebraic expression with any number of terms, we call it generally as polynomial. Okay. So now we will discuss about how to add two algebraic expressions together. See, understanding of addition of algebraic expression or expressions is very important because it has a huge application as we move to the higher classes. Now let us consider one algebraic expression 7x squared minus 5x plus 3. As I had advised in my earlier videos, please have a paper and a pen so that you can write down when I instruct the algebraic expressions, or when I take examples, you can write it down and then you follow what I am saying. You will be able to better understand the video. So let us take one algebraic expression 7x squared minus 5x plus 8. 7x squared minus 5x plus 8. Okay. Take another algebraic expression 9x plus 2. So first one is a trinomial. It is an algebraic expression with 3 terms. 7x squared minus 5x plus 8. Second one is 9x plus 2. Now let us add these two algebraic expressions together. So what you will have to do is, you first write down the first algebraic expression 7x squared minus 5x plus 8. Okay. And below the algebraic expression, you start writing down the terms of the second algebraic expression. Now in the second algebraic expression, which is 9x plus 2, you do not have a term with x raised to the power 2, isn't it? You have only 9x and 8. So you start writing down the terms of the second expression below the like terms of the first algebraic expression. So in the first algebraic expression 7x squared minus 5x plus 8, you take the first term of the second algebraic expression, check if there is a like term. Okay. So you take the first one 7x squared. What are the variable factors? X comma x. You take the first term of the second algebraic expression. It is 9x. So the variable is x. And we said for two terms to be like terms, there are 3 rules. 1. Number of variables should be equal. we said variables should be the same. And the third thing is the exponent or exponents of those variables should be equal in both the terms. Then we call two terms as like terms, isn't it? So take 7x squared, take 9x. The exponent of the variable factor in 7x squared, which is x, the exponent is 2. Wherein in 9x, the exponent is 1. Hence, 7x squared and 9x are not like terms. They do not satisfy the third rule. Okay. Now you take the second term in the first expression, which is 5x minus 5x, isn't it? So minus 5 is a numerical coefficient, numerical factor, exclude it. Which is the variable factor? X. And in 9x, which is the variable factor? Which again is x. Right? Now, the number of variables are the same. You have x, and here also you have x, one variable. The variables are also the same, right? Here you have x and here you have x. So the number of variables are the same. In minus 5x also there is only one variable factor. In 9x also there is only one variable factor. Hence the numbers are the same. The variable factors are also the same. It is x on both sides. And if you check the exponents of both, they are also equal. It is 1. Hence, minus 5x and 9x are like terms. So you write 9x below minus 5x. So you have already written the first algebraic expression. 7x squared minus 5x plus 2. You have written. Okay. So you took the first term of the second expression, 9x. Right? So the first algebraic expression is, 7x squared minus 5x plus 8. The second one is 9x plus 2. Okay. So you took the first term 9x and you checked with 7x squared. They are not like terms. But 9x and minus 5x are like terms. So you write 9x below minus 5x. Okay. You write it below minus 5x. Now you check the next term in the second algebraic expression. It is 2. The only factor of 2 is 2 itself. It is a constant, right? It is a number. So in the first expression you find 8, which is again a constant, which is a number. So write 2 below 8. Okay. So now in your paper, the order will look like as follows. You have 7x squared. Under 7x squared, there is nothing. Then you have minus 5x. Under minus 5x, you have 9x plus 8. Right? Below plus 8, you have 2. Right? Now you add. Right? So under 7x squared there is nothing, which means 0x squared. It is 0, right? So 7x squared plus 0x squared is 7x squared. You have minus 5x below 9x, minus 5x plus 9x, right? It is 4x plus 4x, isn't it? So you have 7x squared plus 4x. You have plus 8, you have plus 2. Add it, you get plus 10. So you get the answer as 7x squared plus 4x plus 10. 8 plus 2 is 10 as the answer. So if you have any number of terms in both the algebraic expressions, like how we had added in our example, all you have to do is first write down the first algebraic expression. Okay. If you can group the like terms in the first algebraic expressions, group it. For example, if in an algebraic expression you have 7x squared plus 2x squared minus 5x plus 8, the 7x squared and 2x squared are like terms. Add it. Make it 9x squared. Simplify it. Okay. So the simplified version of the algebraic expression, the first algebraic expression, you write down in the first row. And you take term by term from the second algebraic expression. Take the first term. Check if there is a like term by applying our rules in the first algebraic expression. Take the first term of the second algebraic expression. Verify if there is a like term in the first algebraic expression, and if there is a like term, right, put the term under the like term of the first algebraic expression. Okay. So if there are no like terms, so you are taking a term from the second algebraic expression. In the first algebraic expression, there are no like terms. What do? Just write it outside of the terms of the first algebraic expression. Okay. For example, the second you have an x cube. You have 7x squared minus 5x plus 8, and in the second algebraic expression you have x cube plus 9x plus 2. What do? See, x cube is the first term and there are no x cube in the first algebraic expression, isn't it? So all you have to do is put 0x cube at the start of the first algebraic expression, put x cube under it. 0x cube is nothing but 0, right? But put 10x cube in the first algebraic expression and then write your x cube under it so that you will not commit any mistakes. So this one checking you will have to do for sure. Okay. So in this fashion, we can add any number of algebraic expressions one by one and find the final result of adding multiple algebraic expressions. Alright. So when we talk about subtraction, if you have to subtract one algebraic expression with another from another algebraic expression, you have to follow the same rules. You first write down the first algebraic expression. You take term by term from the second algebraic expression. Okay. Write it down below the like term from the first algebraic expression, like how you were doing it for addition. And since this is subtraction, change the sign of the like terms or the terms from the second algebraic expression. For example, if we have to subtract from 7x squared minus 5x plus 8, the algebraic expression 9x plus 2, then you first write down 7x squared minus 5x plus 8, and then you take the first term 9x, write it below the like term, from the first algebraic expression, which is, minus 5x, put 9x below, put 2 below 8, and now change the sign. So you make 9x as minus 9x and plus 2 as minus 2 because it is subtraction. Now you add it, right? You get 7x squared, you have minus 5x minus 9x, you get minus 14x, you have plus 8 minus 2 plus 6 as the answer. Alright. So this is very simple, but what you need is a lot of practice. நிறைய practice பண்ணாதான் இது மைண்ட்ல போய் உட்காரும். So you require lot of practice to ensure that you understand the addition and subtraction very, very clearly. Okay. So we will talk about multiplication of monomial with binomial, monomial with monomial, and in general multiplication of polynomial with polynomial in our next video. Okay, thank you.